Hi guys. Okay, so now let's look at some of the calculations involving the use of first law of thermodynamics, which is E is equal to Q plus W. And here we are seeing a situation in which there is the hot air balloon and there's a gas inside this balloon which is getting heated up, and it gets the molecules inside the gas get excited, and the gas becomes lighter and it begins to move up, and eventually the balloon begins to expand. So we have the initial volume of the balloon, which was 4.00 10 to the power 6 liters, and then we have the final volume, which is 4.50 10 to the power 6 liters. We are asked to calculate the delta E value, which is the change in energy, and the amount of heat that is given to this balloon, to the gas in other words, and it expands is positive 1.3 10 to the power 8 joules of heat. And since it is positive number, which means it's absorbing, obviously it's getting heated up. So that is an endothermic reaction. And all this is happening at 1 atmospheric pressure. So here are a few things we are going to first write down. First is that what formula are we going to use? W is equal to negative P delta V. So why are we using some of the things here? W is equal to negative. Why are we using W is equal to the negative number? Because the gas is expanding. So keep that in mind, that based on my previous explanation in my previous video. So anytime the gases are expanding, the formula you're going to use is W is equal to negative P delta V. But if the gas is compressed, then it is positive P delta V. So in this case, obviously, the balloon is being heated up and the balloon is expanding. So negative P delta V. All right. So next we are obviously, I'm going to just like to write down everything in one place. So here we have the next point is Q. Q is a positive 1.3 into 10 to the power 8 joules. So clearly the heat is being added into the system. So this is an endothermic reaction or endothermic process. Endothermic. Okay, next is the endothermic. Okay, next is the change in volume. So delta V. Delta V is change in volume from the initial stage to the final. So basically it's V final, the final volume minus the initial volume. Okay, initial volume. Okay, so now what is that? Let's do these calculations. Here we are given 4.50 into 10 to the power 6 liters minus 4.00 into 10 to the power 6 liters. And that gives you 0.500 into 10 to the power 6 liters. So that is the value of delta V. All right, now here's a very important thing. Fine, we understand this formula that we are going to use is delta E, that is a change in the internal energy, is a manifestation of the amount of heat that you provide to the system and the amount of work that either the system does or the work done on the system. So that's the W. Now, the story here is that you are going to use the values. Remember that W units, the W is negative P delta V. So P is going to be in atmosphere, right? And volume is going to be in liters. So that's fine. It can be liters dot atmosphere or atmosphere dot liters, either way, it still means the same. Okay, so either way you can write them, but that's the unit. However, the Q, remember, the unit that is being used here is in joules. So this joules is this joules. This is the joules. Joules. Okay, so that is the unit of heat here. Okay, so if this is in joules, then we need to have work also in joules. There has to be a conversion factor that involves the liters dot atmosphere to be converted to joules. And we are given that 1 liter dot atmosphere is equal to 101.3, 101.3 joules. And I'll just write down here joules. Okay, so this is what is given to us. In other words, what are the two conversion factors? 1 liter dot atmosphere over 101.3 joules, or 101.3 joules over 1 liters dot atmosphere. Okay, so these are the two conversion factors. And now we will have the, we're going to just change. First, we will need to find the value of W. W is equal to negative P delta V. So what is P? P is given to us is 1 atmosphere. And we just now found out the value of delta V. So we are going to just plug in these numbers. Negative 1.00 atmosphere times 0.500 into 10 to the power 6 liters. Okay, so when you finish the computation, then W becomes negative 5.0 into 10 to the power 5 liters atmosphere, or atmosphere liters, you know, either way. Okay, so this is the, let me just change it to, oh, because the units are in liter atmosphere, we'll leave it like that. Okay, so this is our value of W. Next is, we are going to convert it to joules. So convert liters dot atmosphere to joules. And which of the two conversion factors are you going to use? You're going to use this one. Why? Because liter atmosphere in the denominator allows you to cancel it out. Okay, we want this. This is what we want. The unit that you want is going to be in the numerator, and the unit that you want to cancel out is going to be in the denominator. Okay, so this is how you, and this is the wanted units, and this is going to be the units that you want to cancel out. So now we are going to write this down. Negative 5.0 into 10 to the power 5 liters dot atmosphere times, now we want the joules, right? 101.3 joules, 101.3 joules over 1 liter dot atmosphere. And this is going to, now you're going to basically cancel out the liters and atmosphere, and you are left with the unit of joules, which is the one that you want. So this is how the dimensional analysis works. So what do you get as a final value of W now? W is equal to negative 5.1 into 10 to the power 7 joules. Okay, so that's the value. Next, what you're doing next is, now you're going to just plug in the numbers. So delta E is equal to Q plus W. Now what are we given regarding the Q? Q is positive 1.3 into 10 to the power 8, okay, joules, okay, and then plus negative 5.1 into 10 to the power 7 joules, okay. So when you finish this, the value of delta E comes out to be, the value of delta E is 8 into 8.0 into 10 to the power 7 joules. To put it at the power 7 joules. Okay, and so now here's something you have to understand, the last and the final step, and that is because the value of delta E comes out to be positive, therefore the internal energy of the system increases. Internal energy of the system, and the system in this case is that balloon, the gas, okay, the system increases. All right, so this is the understanding of this law, the first law of thermodynamics and the applications of it. So the absolute most important piece here is that just make sure that the values of these two are, the units of these two are the same, and they should be in joule. So don't forget to convert them. So this is the conversion factor for the two. All right. Okay, so I hope that that was easy, and thank you for watching. Bye-bye.